Hello, my name is Srinivas Bobba. Today I am presenting my mini project um, for the Applied Artificial Intelligence course. The title of the project is Machine Learning Approach for Early Detection of the Cancer, Insights from Wisconsin Diagnostic Dataset, Coimbra Dataset, and Mammographic Mass Dataset. My group for the mini project is Mini Project 19. Sorry. The agenda for the today's presentation: introduction, problem definition, data exploration, data pre-processing, methodology, implementation, experiments and results, comparative analysis, conclusion, and recommendations. In 2020, about 2.6 new cases of breast cancer occurred in the women. The table shows the top 10 countries with the highest rate of female breast cancer deaths and largest number of fatalities in the same year. This puts significant strain on even the best healthcare systems globally. Regular mammograms and screenings are more important for early detection, improving the treatment results. The study emphasizes using machine learning algorithms to identify the features that help predict if the tumor is malignant or benign. What is the important of doing or beneficial for doing this study? The healthcare providers early and correct diagnosis will stop the spread of the cancer to the other parts of the body, reduce the need for healthcare, and significantly lower the healthcare costs. For patients, early and correct diagnosis can increase the survival rate and eliminating the risk of surgery. Problem definition: we aim to predict if the breast tumors are malignant using the features from the three datasets: Wisconsin, Coimbra, and mammographic mass. Machine learning is crucial as it efficiently analyzes the complex patterns in the data, improving the accuracy of the breast cancer detection through machine learning algorithms. About the dataset, we collected the datasets, that is the vectorized data collected from UCI University of California, Irvine machine learning repository, which is accessible to the public for research purposes. The brief description of the datasets: the Wisconsin dataset, that is purely image-based features from the breast mass fine needle analysis. The attributes include mean, SE, and worst values, and the binary variable for the cancer presence, either it is benign or malignant. And the second data set, the Coimbra data set, the clinical features from 64 cancer patients and 52 of them the controls. That means healthy people, and 10 predictors from the biometric and bioinformatic and blood analysis. The binary variable for cancer presence is malignant or benign. The third dataset, mammographic mass dataset, the features from mammograms, that is one of the important, the shape and margin, age, and by rates. The binary variable for the cancer presence is either benign or malignant. First, we conducted the experiment on first data set, breast cancer on prediction analysis on Wisconsin data set. In each stage, we did the following steps: data exploration and pre-processing, data transformation and feature selection, build the model using supervised machine learning algorithms, and evaluate the model performance and present the results. In the first stage, if you see the data exploration on the Wisconsin data set, there are the 569 instances and 30 features. When you see in the diagram, each feature represents with the 0. That means there is no missing values. We retrieve the data by using the URL from the repository data, and these are the column names: ID, diagnostics, mean radius, mean structure, mean parameter, mean area, and similarly it is for the worst and SE. So we extracted all the data sets, and we can find that 569 rows and 30 columns. That those are the features. First, before going for the analysis, we did the hypothetical testing on the data set. The reason for why we did hypothetical testing is that is a statistical method to make the inferences about population based on the sample, involving formulating null and alternative hypotheses, collecting and analyzing the data, setting significance level, conducting the statistic, and draw the conclusions based on those results. When you see here the hypothesis testing results, t-statics, p-value, critical value, degree of freedom, confidence level, and alpha values. The results of the hypothetical test indicates a statistically significant difference in the mean radius between the benign and malignant tumors. When you see in the results with a static of minus 22.11 and extremely low p-value 1.6, that means it rejects the null hypothesis. This suggests that mean radius of benign tumor is significantly less than the mean radius of malignant tumor. The t-statics falls far beyond the critical value of 95% confidence level. This provides strong evidence to the support for this conclusion. So when you see in the right side of them, this is the class count. Benign cases are 357, that means no cancer, and malignant cases are 212. So based on this plot, we can come to the conclusion that whatever the data we have at this moment, that is the imbalanced data set. So data pre-processing, feature grouping, group the features into worst and mean and see the categories, and diagnostic the results visualization. The visualization helps us to distribution of the each feature with respect to the diagnosis of malignant, benign. This can help us to identify the features that are more indicative towards the diagnosis. It also allows for a quick identification of any significant difference, in the future distribution of the diagnosis. So the next one is correlation analysis. We calculate the correlation matrix as seen in the figure for all the features, we excluding the ID and diagnosis. So the main advantage of correlation matrix, that visualizing the correlation with the heat map, is it allows us to quickly identify which features are highly correlated with each other. Highly correlated features can cause issues in machine learning models such as overfitting or instability. By identifying these highly correlated features, we can make informed decisions about features. And additionally, the heat map provides visual representation of the strength and the direction of the correlation, making it easier to interpret the relationship between the features. So after performed the correlation analysis, we remove the highly correlated features that is greater than 0.9. That means 90%. So previously we have 30 features in the data set. After performing the correlation, only the select the 20 features for the further analysis. Data transformation, standardization, scale all the numerical features using standard scale function and PCA dimensionality reduction. The PCA is used for the dimensionality reduction and to know the variance of the data set using the singular value decomposition data array. That PCA is an unsupervised approach for reducing the linear dimensionality of the data set. The information is linearly projected on the principal component orthogonal base. The most variance explained in the first component followed by the second on the PCA used to the dimensionality reduction. There it determines, when you see in the diagram, it determines the looking at the cumulative variance, and we identify the optimum number of the components. So if we may choose the 10 principal components as they explain more than 90% of variance in the data. If you see here, it is across the 10 principal components. So we took the 10 principal combination. So the visualization of the first two principal components in PCA analysis serves a valuable tool for gaining the insights into the complex data sets. The visual approach may not enhance the communication result, especially non-technical areas. So it into two clusters, either 0 or 1, either cancer and 1. It will be very useful for the analysis. And features, we identify the most important features in each principal component, and we created the new data set, that is the 569 rows. Previously it was 20 after correlation. Now after principal PCA, we found only these 10 are the more important for the analysis. So 569 into 11 data sets for analysis. Sorry. The 10 principal components under response column indicates the cancer one and non-cancer. So based on this one, we find the new data set 569 with the most important variables like features, that 10 features. So it will be provided for the next analysis, the building the models. So methodology, building the models using supervised machine learning, we decided to use these are the machine learning algorithms we decided to use. Some of them are the linear models, and some of them are the non-linear models, and some of them are ensemble models and instant-based learning and neural networks. And the remaining are some remaining are neural networks. Logistic regression, linear model for binary classification, and decision tree, nonlinear model for classification and regression, random forest, ensemble learning method using multiple decision trees, and K nearest neighbors, instant-based learning algorithm, and support vector machines, linear and nonlinear classification algorithm. MLP, feed-forward neural network with multiple layers, and artificial neural networks, ANN, for interconnected nodes arranged in the layers, and conventional CNN, specialized neural network for processing grid-like data. Model evaluation. The performance metrics are chosen for our analysis because due to the imbalanced data set. That is the reason we chose these are the performance metrics to compare the models with various machine learning algorithms. Sensitivity through positive rays, specificity through negative rate, and F1 square, harmonic mean of precision and recall, accuracy, overall correctness, and overall accuracy of the model, and AUC, area under the current, that is the discrimination ability. So after deciding the performance metrics, this is the implementation of the our project. So that is we followed the CRISP-DM, crash standard process of data mining, that is widely used framework for data mining process. It involves the six stages: business understanding, data understanding, data preparation, modeling, and deployment. Based on this this model, we extracted the data from Irwin dataset, and the data is pre-processing, split the data into train and test, and model building and model evaluation. These are the models we use, and these are the performance metrics. This is the breast cancer prediction process model for our project. The results from this analysis, we got this confusion matrix, logistic regression, and decision tree, random forest, and CNN, k-neighbors, and support vector machines, MLP, and ANN. So these are all the AUC curve and sensitivity, specificity, and classification report for the CNN, ANN, and SN, and CNN and ANN and MLP. So the advantage of confusion matrix, able to show the performance of the confusion matrix set of data and true positives in the row, correctly predict the positive, that is the TP, correctly predicted positive instances, true negatives, correctly predicted negative instances, false positives, incorrectly predicted positive instances, and false negative, incorrectly predicted negative instances. So in all this scenario, so as a healthcare prediction of the cancer, so the main aim is to minimize the false negatives. That means this column. When you see, if you see here in logistic regression, here is the 6, and the decision tree is 8, and here random forest is 7, and CN is 3, and AN is 1, and it is 6, and this is 5. So this is the false positive. Yeah. So based on all these results, we formulated the calculate the sensitivity and specificity and accuracy, and based on that one, we will come to the one. We came to the one conclusion. So when I see this diagram, so the model comparison for the all by using all the algorithms, the overall accuracy is 90. Logistic regression, it is saying that 97.5%, and the decision tree almost 100%, and random forest is 99.5, and k-neighbors is 100%, and SVM is 98%, and MLP is 95, and CNN is 93, and ANN is 96. When you see in this diagram, this is the sensitivity and specificity comparison. The reason why we are focusing more on the sensitivity, the main aim is to reduce the missing cancer cases. So that's the reason we are working on this one. Based on this comparison, we can come to the conclusion, if our primary concern is the accuracy, then the decision tree, random forest, k-neighbors, and support vector machines, those achieved the good accuracy. But however, the training accuracy is alone might not be represent the model's generalization on new data. So additionally, it is crucial to consider the metrics like recall, precision, and specificity, especially in medical applications where false negatives, that means missing cancer cases, can be critical. Based on the whole analysis and considering the medical needed, so we can come to the conclusion that logistic regression and support vector machine and k-neighbors seems to be strong in the prediction of the cancer. So we can use either of the algorithm to predict the cancer. And next, experiment 2, the breast cancer prediction analysis on Coimbra dataset. As I mentioned in the previous Wisconsin dataset, the same steps and the same algorithm, same metrics we followed on this one. First, data exploration and pre-processing, data transformation and feature selection, build the model using supervised machine learning algorithms, evaluate the model performance, and present the results. So the breast cancer Coimbra dataset consists of 116 instances and 10 features. It is a very small dataset. When you see here in this figure, all the features having null values is 0. That means no missing values. And we extracted the data from the website by using the CSV file. And there are the 116 rows and 10 columns. When you see here the class count, 2 is the cancer cases and 1 is the non-cancerous cases. That means 64 and 52. Yeah, so it is also slightly imbalanced, but it is a very small data set. Data pre-processing. Here the first what we did here, feature identification. Originally, as I mentioned in the previous slide, the classes were represented as 1 and 2, but it is very confusing. So we converted with them more conventional representation where 0 often signifies one class that is benign and 1 for the significance the malignant. So diagnostic visualization of the result, yeah, as I mentioned in the previous analysis, they plotted the histograms for each group and the diagnosis. Here, if you see here, age, BMI, glucose, insulin, leptin, adaptin, and resistin, and MCP, and these are all the features against the on this one. And correlation analysis calculated the correlation matrix for the all the features including that one, but we didn't see much correlation between that one. So I did not remove any of the features because I didn't see more correlated to each other. So finally, we selected 10 features for the further analysis. Data transformation. Here, scale the numerical features using the standard scaler and PCA. On the advantage of PCA is the principal component analysis by dimensionality reduction. We applied PCA, but unfortunately, we didn't see the no apparent clustering here. So that means we are not using PCA anymore. So visualization of the data distribution confirmed that linearity we already seen in the previous slide. And feature selection, identify the most important features that is called variable importance by using the extra tree classifier. So it has given the all the important features by weight. For example, if you see glucose, that is for 0.41 and age 2 and resistin 0.16, BMI 0.07, insulin 0.05, and HOMA 0.05, leptin also 0.0. Adiposity it doesn't have any weight, maybe that's not. So because of the small data set, I decided to not discard any of the features from this data. So I used all the features for my analysis. So as previously mentioned, this is the confusion matrix, true positives and false negatives, and these are the accuracy result and classification result. Based on these results, we compare all the models. Here, if you see here, logistic regression is the 97.5% accuracy, and decision tree is the 100%, and random forest 99%, and k-neighbors 100%, 98% SVM, and MLP is 95%, and CNN is 93%, and ANN is 96%. When you see here, ROC curve logistic regression has 0.98% and decision tree has 8.7, and random forest 92%, k-neighbors 94%, support vector machines 9. Based on this analysis, we came for the conclusion that decision tree and k nearest neighbors model exhibit potential overfitting due to the perfect training accuracy. The reason is it is the very small data set and that too in balance. So that's the reason those are overfitting. And random forest, if you see here, random forest and 99%, and support vector show good generalization. Support vector machines, good generalization, both having the good accuracy. And not only the accuracy, if you see the sensitivity and specificity, for example, if you see SVM, it is correctly classified. That means 100% sensitivity. And the other one is generally a random forest. Random forest also having 100% sensitivity. So maybe random in the Coimbra data set, these two are very best predicted algorithms. Neural network, if you see the neural network, CNN, MLP, and ALN, they also having the good accuracy, but unfortunately, they demonstrate competitive performance, outperforming the ANN. So always better to select the traditional algorithms when we have the less number of the samples in the data set and relatively small data set. So finally, I came to the conclusion that random forest or support vector machines show, show the good generalization. The next experiment, breast cancer prediction analysis on the mammographic data set. In my analysis, this is the third data set. In the same algorithms, whatever I applied in the previous two data sets, like linear, non-linear, ensemble, and neural network algorithms. The 8 algorithms I applied in the third data set. Here, the same steps we followed in that one: data expression, data pre-processing, data transformation, and feature selection, build the models using supervised machine learning algorithm, and evaluate model performance and present the results. So the first step is data exploration. If you see here, it consists of 961 samples and 6 features compared to previous 2 data sets. That means Wisconsin data set and Coimbra data set. It is relatively big. So we extracted the data and one there is no missing values too, and we extracted the data from the by using the URL, and there we got what 961 rows and 6 columns. When you see the class distribution here, cancer one is 445 samples and non-cancer one is 516. Compared to previous two data sets, still it is imbalanced, but it's okay for the analysis. So data pre-processing. Here, what we did, impute the function. It converts the column to numeric and non-numeric values with median, and we use the replace function to replace the outliers in numeric columns with an upper limit, and gnorm function, it gnormalizes numeric value to the column. Decode function, decode numeric values into the categories name. Consolidate function, consolidate the category values in a given column. And also finally use the function is one-hot encoding. It encodes the categorical data, creating binary value in a new column based on the specific category value. So these are the functions we use in the pre-processing data for the data cleaning and pre-processing. And so data visualization for the mammographic data set. If you see here, period and ages against this one, these are the distribution of the samples. When you see the age versus severity, that is our target variable. Here we can see the distribution is nicely distributed, like healthy controls and cancer patients. Here in by rates also, they are the distributed, normally distributed. When you see the correlated matters, unfortunately we didn't see any correlated. So there is no point of taking out any of the features from the analysis. So I continued with all the features with the analysis. So Data transformation. Next step is data transformation. Here we split the sets built for the scikit-learn model to split the training data set, that is 75% training and 25% testing. Feature preparing. Use a simple imputer for missing values, mean of numeric and mean of frequent for categorical. Applied standard scalar for numerical features for standardization. So the third, we did that column transformer to identify a preprocess and numeric to categorical feature, and pipeline for the transformation. Constructed the pipelines for numeric and categorical transformation. In the similar way, in the previous mentioned, applied one hot encoder to handle the categorical variable and ignoring the unknown values. Feature scaling, standardization of feature using standard scalar and independently for the training data sets. The last one is the feature selection. Identify the most important features. We call it as variable important by using the same extra tree classifier. Based on that feature selection, we got these are the important features. Because it is very less features for the data set with 961 samples, when you see the weight of this one, Bayes has the more weight and the next density followed by age, shape, and so because of the less samples, we did not take out any of the features from the data set. We continue to use all the data sets. So these are the results from the memographic data set analysis. So logistic regression, decision tree confirmation, random forest, and SSP, and k-neighbors, support vector machines, confusion matrix, and these are all the classification reports. So based on that one, we produce the comparison of the results. So here logistic regression 84% and decision tree is 95% and random forest is 95%. 94 is on k-neighbors and SVM is 86% and MLP is 82 and CNN is 82 and again ANN is 82. So when you see the comparison of logistic regressions and the sensitivity and specificity, so by looking at AOC and model accuracy and specific, we came to the conclusion that ensemble models, random forest and k-neighbors outperform for individual models, random forest and outperform, and support vector machines and logistic regression gives the good balance between the sensitivity and specificity. For example, if you see here logistic regression, the sensitivity is 79 and here is the specificity. And when you see here support vector machine, here good sensitivity and specificity. So neural networks offer competitive performance, but their interoperability may be limited compared to the traditional algorithms. So the better to select the support vector machine or logistic regression. So after seeing all the analysis from the three data sets, we came to the conclusion that compared to the neural networks and the traditional machine learning algorithms, they are working fine with the data sets, all the three data sets, especially logistic regression, that is very good for the binary classification. And next one is the support vector machine. So these are some challenges while doing this project. The first one is data variability. So when you see the data sets, first one is they extracted the data from fine needle analysis. This second one is Coimbra data set, and that is from bioinformatics and mass spectrography data. And the third one is mammography data. That means both are all the three data sets are diverse data sets. That means the collection methods, formats, and scales, and the integrations, these are all having the challenges while applying the machine learning algorithms. And the another big problem is those are imbalanced data set. More benign cases can imbalance data, affecting the model's accuracy. And Model interoperability, complex models, for example, neural networks, CNN and ANN, they can be hard to interpret because of the hindering the trust in clinical settings. And ethical concerns using machine learning healthcare raises ethical issues like privacy, consent, and algorithm biases. But here in this analysis, uh, uh, we don't see any privacy issues because we collected the data from the UCI repository that is the publicly available for the researchers or any analysis purpose. Generalization. Models may struggle to generalize to diverse populations, requiring robustness and across the different demographics. For example, if you take the population in Sweden, and if you don't take the population from Asian countries, then that is not good to generalize to further conclusion. So population also not important. That means a demographic population. So that is also one of the challenge in this analysis. So my reflection on the experiment one, the Wisconsin data set, the hypothesis testing suggested that mean radius of benign tumor is less than the malignant tumors. The key features are radius of the mean, structure of the mean, smoothness of the mean, and compactness and concavity, symmetry, and factile dimension means radius. The similar radius SE and forest, all the features are verified. They are very important features for the building the model and analysis. And machine learning algorithms applied on the data set logistic regression, decision tree, random forest, SVM, MLP, CNN, and ANN. High sensitivity, minimizing the false negative was crucial. Based on this one, the recommendations is for high sensitivity logistic regression and support vector machine k-neighbors seems to be some strong contenders for the cancer prediction. Next, reflection on experiment 2, that is Coimbra dataset. So glucose, age, resistance, and BMI and insulins were indicative tumor nature, and machine learning algorithm same applied what I previously I told. And based on these results, we observed that decision tree and k-neighbors models exhibit the potential for the overfitting. Here also random forest and support vector machines, so good generalization. And neural network, especially CNN competitive performance, outperforming the ANN. So here also only traditional algorithms are showing the good performance on this data set. And the third one is bias and density age are more important. The same machine learning algorithms applied on that one. The observations from those ensemble models, again, random forest k-neighbors outperform the individual model, showing the power of combining multiple learners. Support vector machine, logistic regression, they are giving the good balance. In all the scenarios, support vector machines and logistic regression is giving the good performance compared to all the models as well as in the all the data sets. So neural networks offer giving the better performance, but their interoperability may be limited because of that traditional machine learnings are very good for this analysis. So in conclusion, our analysis across Wisconsin, Coimbra, and Menabuk mass data set highlights the significance of the machine learning in breast cancer diagnosis. So features like radius, age, insulin, density, glucose, resistance, and specific biomarkers are very important. We use the different algorithms, but in the random forest, SVM, those are all very good for in terms of accuracy. But if you see that sensitivity and precipitation, random forest, SVM logistics regressions are good for the analysis. Ensemble models and SVM demonstrate generalization. So moving forward, validating the models and diverse data set, collaborating with the experts and adapting the involving research, key successful implementation of clinical setting. So finally, detecting the breast cancer early is more important by using the machine learning providers, valuable tool for the essential part of the breast cancer treatment. This is my conclusion from the analysis on 3 data sets with the 8 algorithms and changing the what is the parameters and comparing the results with the using the matrix. So these are the general recommendations based on this analysis. For the technical perspective, consider the task-specific requirements for the model selection and prioritize high sensitivity for early detection in the breast cancer diagnosis. Evaluate the trade-off between the model complexity and interoperability. Ensemble models, the random forest can offer improved performance, and regularly validate the models on independent data sets to ensure generalizability. Collaborate with the medical expert for more comprehensive understanding of the feature importance and model outputs. These are the general recommendations from the technical perspective, and these are the general recommendation for medical perspective. Regular monitoring, monitor individuals with malignancy indicative feature regularly, focus assessments. So from the three analysis, we came to know that there are the important features, that is the glucose, age, resistance, and BMI and insulins. And we can tailor those things with the screening by using the based on by rates, density, and age. So based on this important feature, patient can educate about the feature significant, encourage the regular checkup, just like mammography, and consult the healthcare professionals for personalized advice. So based on the analysis, we came to the conclusion that these are the more important features. So that means after certain ages, also menopause is also more important for the women. So after that, they will go for the regular mammographic test, and as well as the resistin and BMI. So those are all very helpful for the early detection of the at least first screening. So these are my general recommendations on that one. So this is the final slide for my presentation. So here I believe that my project meets the grading criteria 5, because here the data sets, I use 3 data sets vectorized from RCA repository, breast cancer Wisconsin, breast cancer Coimbra, and mammography mass data set. The tasks I performed here, data engineering, data exploration, understanding, handling missing values, variable encoding, feature scaling, feature creation, handling outliers, feature selection and feature extraction, cross-validation, machine learning algorithms. A total of 8 machine learning algorithms use logistic regression, decision tree, random forest, k-neighbors, SVM, MLP, CNN, and AN. Performance metrics I used here: sensitivity, that is the true positive rate, specificity, F1 score, and accuracy and area underscore comparison of the model between the two or models algorithms on the 3 different data sets. So well documented results, documented all the results and final conclusions, reflections, and recommendations are well explained. Yeah, thank you very much.